Good day and welcome back to my channel. Today we will be looking at part 3 of short differentiation. As we discussed previously, before we begin our short differentiation, it's necessary to do some preparation. We must ensure that there's no brackets, there's no long division lines, there's no surds over variables being differentiated, and there's no variables being differentiated as denominators. I would suggest you memorize these steps as you will not get them in an exam. Example 1, we have f of x is equals to 3 multiplied by the root of x plus 1 over the root of x. So we're going to use the preparation steps as a checklist before we do our actual differentiation. So there's no brackets in this question. There's no long division lines. However, there is surds over variables we're differentiating, and there's variables we're differentiating as denominators. So we'll do some simplification so that we can sort that out. We can change the square root of x to x to the power half as per our normal laws of exponents. Then, in the next step, we can bring this x to the power half to the numerator as long as we change the sign of the exponent. Right, the simplification is complete, and now we can proceed to do our actual differentiation. Remember, it's important to note that when we do the differentiation, we should change our notation to the differentiation notation. So f of x becomes f prime of x, and now we can do our differentiation. We notice that both the terms will make use of the power rule. So we take the exponent, which is a half, and we multiply it by the coefficient, which is 3. And this becomes 3 over 2. And the x to the power half, we remove 1 from the exponent. So it then becomes x to the power negative a half. So that's differentiating the first term. Now let's differentiate the second term. To differentiate the second term, we're going to take the negative a half exponent and multiply it by the coefficient, which is 1. We'll be left with negative a half. And we're going to subtract 1 from the exponent. So minus a half minus 1 is just negative 3 over 2. And our differentiation is complete. We might, depending on the question, be required to present our answer with positive exponents and no fraction exponents. By taking the x to the power negative half to the denominator, the exponent becomes positive. And we can do the same thing with the second term. Now, we can get rid of the fraction exponents by changing the exponents to surds. Remember, the numerator in the fraction of the exponent is the power of x, and the denominator is the power of the root. So x to the power half simply becomes the square root of x. And changing x to the 3 over 2 becomes the square root of x to the power 3. Guys, for a more enhanced learning experience in mathematics and physical science, please check out our Instagram for how to register for ACE Academics tuition. Right, let's do the second example. We have f of x is equals to 1 minus x all squared divided by 2x. Here we see we have a long division line and we have brackets. So we have to sort those out before we actually do the differentiation. So we're going to square this binomial in the numerator. And when we do first times first of 1, it's just 1. 2 times first times last is negative 2x. And last times last is positive x squared. And this is all divided by 2x. Now we got rid of our brackets, but our problem is the long division line. And we can either get rid of the long division line by giving each numerator its own denominator, or by cancelling out. In this case, I'm going to give each numerator its own denominator. I must also remember that I do not want any x's in the denominator. So whichever x's are in the denominator, I'm going to bring it up to the numerator, but I can do that only if I change the sign of my exponent. The 2x and the 2x cancel out, and we're simply left with minus 1. And in the last term, we're simply left with a half x, as one of the x's cancel out on the numerator, and it cancels out with the x in the denominator. Now we're ready to do our actual differentiation. The first thing in the step when doing our derivative is we change our notation. So f of x becomes f prime of x. And now we differentiate each term. The first term, the exponent is negative 1. So it's the power rule. We take the exponent and we multiply it by the coefficient. So a half multiplied by negative 1 is simply negative a half. And we remove 1 from the exponent. So that's x to the negative 2. The derivative of negative 1 is just 0 because the derivative of a constant is 0. And the derivative of positive a half is just a half. Please refer to my first video if you're still struggling with this step. Now, for the final step is to ensure that we don't have any fraction exponents or negative exponents. So f prime of x becomes negative 1 all over 2x squared. So I can take the x to the denominator as long as I change the sign of the exponent, plus a half. Right, now let's look at a third example. We have y is equals to t to the power of a quarter minus t to the power of negative a quarter all squared. Now, according to our preparation steps, we need to ensure that there's no brackets. So the first thing we'll do is get rid of the brackets by squaring the binomial. So the first step is first times first. So it's t to the power of a quarter times t to the power of a quarter, which is basically t to the power of a quarter all squared. The second step is to add 2 times the first term, which is t to the power of a quarter, times the second term, which is negative t to the power of negative a quarter. And the last step is to add the last term, or the second term, squared. So it's negative t to the power of negative a quarter all squared. Now to simplify. When we're raising one power to a further power, we multiply our exponents. Please refer to our laws of exponents. And we just left with a quarter multiplied by 2 is simply a half. So we're left with t to the power of a half. For the second term, we have negative 2. And with the t's, we have t to the power of a quarter times t to the power of negative a quarter. Now, when we're multiplying with the same bases, we can add the exponents. So a quarter minus a quarter is simply 0. And t to the power of 0 is just 1. So this remains negative 2. For the last term, negative t to the power of negative a quarter times itself is positive. And when we're raising one power to a further power, we can simply multiply the exponents. So this becomes t to the power of negative a half. Now we're ready to differentiate. So we change our notation and we begin using our 4 rules of differentiation. The first thing we do is we take the exponent in t to the power of a half and we multiply it by the coefficient, so that's a half, and we subtract 1 from the exponent, so we're left with negative a half. The derivative of negative 2 is simply 0 because the derivative of a constant is 0, and the derivative of the third term, we're going to take negative a half and multiply it by the coefficient of 1, so we're left with negative a half, and we're going to subtract 1 from the exponent, so we're left with negative 3 over 2. Now in the final step is just neatening up by making sure all of our exponents are positive and they are not fractions. This is done just by using our laws of exponents. So the t to the power negative a half, I can take it to the denominator and that will make our exponent positive. And I can simply change it to a third because the numerator is the power of t and the denominator is the power of the root. So this simply becomes the square root of t. And the third term becomes 1 over 2, and we take t to the denominator, and as we said, the numerator is the power of t and the denominator is the power of the root, so it's a square root of t cubed. And that's our final answer. If you enjoyed this video, please give it a thumbs up and subscribe to our channel. Also, don't forget to follow us on Instagram at ace.academics.tuition.